India has just revealed one of the most important pieces of its future air power strategy. Footage released on June 11th appears to show the first radar cross-section test model of the Advanced Medium Combat Aircraft, or AMCA, at the Indian Air Force Academy in Dundigal. That may sound technical, but it represents something much bigger. Radar cross-section testing is one of the key milestones in developing a stealth fighter. In simple terms, India is no longer just talking about a fifth-generation fighter, it is now testing how invisible that aircraft might be to enemy radars. But this development also raises a difficult question. Is India finally entering the stealth fighter era? Or is it attempting a technological leap that remains decades beyond its current industrial capabilities? To understand why this matters, we need a little context. The AMCA is India's flagship next-generation fighter program. The project is led by the Aeronautical Development Agency under the Defense Research and Development Organization, better known as DRDO. India intends the aircraft to become a twin-engine stealth fighter capable of competing with fifth-generation aircraft operated by major military powers. The fighter is expected to strengthen India's domestic aerospace sector, while reducing reliance on foreign suppliers. According to current projections, the aircraft could enter service in the early 2040s. The timing is significant. Around the world, the race for advanced combat aircraft is accelerating. China already operates the J-20 and is developing multiple sixth-generation fighter programs. The United States is preparing the F-47 while continuing large-scale production of the F-35. Russia has already fielded the Su-57. Meanwhile, several European sixth-generation programs face uncertainty, delays, and political disagreements. Against that backdrop, India's AMCA represents an attempt to join a very exclusive club. The first major revelation is that India has achieved an important milestone, but the road ahead remains extraordinarily long. Radar cross-section testing demonstrates that engineers have progressed beyond basic concept studies. They are now evaluating how the aircraft's shape interacts with radar waves. This is a critical component of stealth design. However, building a stealth fighter involves much more than designing an airframe. Modern fifth-generation aircraft require advanced radar-absorbing materials, powerful onboard computers, sophisticated sensor fusion, secure data links, electronic warfare systems, and highly efficient engines. Every component must work together seamlessly. History shows how difficult that challenge can be. The American F-35 program required well over $100 billion in development spending. Even countries with decades of aerospace experience continue to struggle with next-generation fighter projects. Europe's FCAS program recently collapsed, despite involving some of the continent's largest defense industries. Therefore, while the radar test model represents genuine progress, it marks the beginning of the hardest phase, rather than the end of it. And that brings us to an even bigger issue: whether India can actually build this aircraft largely on its own. The second revelation is that India's biggest obstacle may not be stealth technology itself. It may be industrial capability. India's aerospace sector has made progress, but its track record remains mixed. The clearest example is the Tejas fighter program. The Tejas was conceived as a relatively lightweight fourth-generation aircraft. Yet the project faced decades of delays, rising costs, and heavy dependence on foreign technologies. Even today, major systems such as engines and various subsystems rely on overseas suppliers. Despite years of investment, India still lacks complete self-sufficiency in critical aerospace technologies. The AMCA demands a far higher level of sophistication than the Tejas ever required. Fifth-generation fighters operate in an entirely different technological category. They function as flying sensor networks, rather than traditional combat aircraft. This reality explains why many analysts expect India to rely extensively on foreign assistance. While New Delhi hopes to build an indigenous fighter, practical requirements may force deeper international partnerships. The question is no longer whether foreign technology will play a role. The question is how large that role will become. And that leads directly to the most important factor shaping the program's future. The third revelation is that Russia may become the decisive enabler of India's stealth ambitions. In January 2026, India's Defense Ministry confirmed that discussions regarding licensed production of the Su-57 had reached an advanced technical stage. Reports indicate that Russia has offered extensive technology transfers, including access to source codes and other sensitive technologies. That offer is highly significant. Most major defense exporters rarely provide such deep access to advanced military systems. For India, cooperation with Russia offers two potential advantages. First, it could provide a near-term solution. If India acquires or produces Su-57 fighters, the Indian Air Force could field fifth-generation capabilities long before the AMCA enters service. Second, and perhaps more importantly, Russian technologies could accelerate AMCA development. Experience gained from operating, maintaining, and producing advanced stealth aircraft could help Indian engineers overcome some of the challenges that slowed previous indigenous programs. Of course, this creates an interesting paradox. The AMCA exists partly to reduce dependence on foreign suppliers. Yet the program may ultimately require substantial foreign assistance to succeed. Rather than replacing imports entirely, India may end up using foreign technology as a bridge toward greater self-reliance. That contradiction could define the project's future. The implications extend far beyond India. For Asia, a successful AMCA would strengthen India's position as a major regional military power. It would also deepen the technological competition already taking shape between India and China. For Russia, cooperation on the Su-57 could secure a major export and reinforce one of Moscow's most important defense partnerships. At a time when global fighter markets are becoming increasingly competitive, India remains a crucial customer. For Western defense industries, the AMCA serves as a reminder that countries increasingly want indigenous capabilities rather than permanent dependence on imported equipment. Even if complete self-sufficiency remains difficult, the strategic goal continues to attract enormous political support. For the broader global balance of power, the development highlights a simple reality. The future of air warfare increasingly depends on advanced technology, software integration, stealth design, and industrial capacity. Nations that master those areas will shape military aviation for decades to come. The most important takeaway is this: India's AMCA radar test proves that the country has entered the stealth fighter race. But winning that race will require far more than building a stealth-shaped aircraft.